This is the Chapter 14 quiz that I gave in 2004, so I may reuse it at some point. But anyway, I'm going to try to go through it. This is probably part 1, so probably going to have 2 videos. Let's just see how long it takes me to go through. But this may be part 1. Okay, so we have 3 multiple choice questions on a test. Each have 4 possible answers. So answers like A, B, C, and D. So I'm just going to guess because I didn't study. So what's the probability that I'm going to be correct? Well, there's only one's going to be an answer, or correct answer. So if B is the correct answer, and I guess, the probability that I'm going to be right is 1 out of 4. So over here we would say 1 out of 4, or 0.25. That would be the answer there. So now if we want to fill out this tree for taking the test, so this, you would think this is question 1. So with question 1 we're either going to be correct, so this would be 0.25, and these have to add up to 1, so this would be 0.75. Okay, and on question 2, that's how this works. On question 2, same thing. The second question, getting it right, is independent of the other, or the first question. So I'm going to get 0.25, 0.75, and that's if I got the first one correct. But it's still going to be 0.25 here and 0.75 here. These are independent events. And then finally, for question 3, I have a lot more to fill out just because of the different paths I could take, but it's all going to be 0.25, 0.75. So if you didn't get this, it's just a matter of practicing with trees a little bit, so I wouldn't worry too much if you did poorly on this quiz, but review this video and move forward, and these trees can be very helpful. So here what we're kind of looking at is this is correct, 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 so 0.25, 0.25, 0.25 here. So that's like the tree branches are ands, so 0.25 times 0.25 times 0.25, because you got a correct and a correct and a correct. Now you're going to have a correct, correct, and not correct. So it's going to be 0.25, 0.25, 0.75. And now we have a correct, not correct, correct. So it's 0.25, 0.75, 0.225. And then we have correct, not correct, not correct. So 0.25, 0.75, 0.25. And then finally, not correct, correct, correct. 0.75, 0.25, 0.25. And then not correct, correct, not correct. So 0.75, 0.25, 0.75. And let's see, not correct. I should have used W for wrong. That would have been better. Not correct, not correct, correct. So 0.75, 0.75, 0.25. And let's see, and then not correct, not correct, not correct. So 0.75, 0.75, 0.75. So now these should add up to 1. But we have to kind of multiply these all out. So there's some shortcuts that you can take, but let's just see. 0.25 cubed is 0. Let's go 3 decimal places. So 0, 1, 6. So 0.016. And then let's see, we're going to have 0.25 squared times 0.75. So that's going to be 0.047. So 0.047, and then every time you have, that's going to be wherever you have 2 correct, so 0.047, right? And I guess that's it. Oh, here's 2 correct, so 0.047, and then now we have 0.75 squared, so 2 wrong answers, times 0.25. So we get 0.141. See that? I'm rounding. So 0.141, 0.141, 0.141, and then finally 0.75 cubed, so 0.422, 0.422. So if you check, you'd add these up, make sure they come to 1. So if you're off just a little bit in the hundredths, that's probably because of rounding, so I wouldn't be too concerned. Alright, so now we can use this tree to kind of help guide us with these probability questions. So, what's the probability, if you guess on all 3 questions, what's the probability that you get none of them correct? So, probability of none correct, that's equal to the probability of the first one wrong and the second one wrong and the third one wrong. So that's equal to the probability of wrong times the probability of wrong times the probability of wrong. So that's going to be 0.75 times 0.75 times 0.75, and we already have computed that, right? It's this branch right here, so it would be 0.422. Okay, now let's look at the next one. Get all of the questions correct. So the probability of all correct, well, that's going to be the other top branch. Now that's the probability of correct and correct and correct. And that translates to the probability of correct times the probability of correct times the probability of correct, and that's going to be 0.25 times 0.25 times 0.25. So all we have to do is look at this branch right here. So we get 0.016. 0.016. Okay, now probability that we get at least one, probability of at least one wrong. Okay, so let's go up to our tree and see if that can help figure out what's going on here. So at least one wrong. So here there's 0 wrong, but here there's 1, 1, 2, 1, 2, 2, and 3. So it's actually going to be all of these. So we could add these all up. You could just add them all up. Or what you can do is, since this totals to 1, just do 1 minus the probability that they're all correct. So that's what we're going to do. So let's go down here and say that's going to equal 1 minus the probability of all correct. Well, we know the probability of all correct. We just did it right up here. So that's going to be 1 minus 0.016. And let's see, that comes out to be 0.984. Okay, last one for this one. Get the probability that you get your first incorrect answer on the 4th question. So I kind of messed up on that. I wanted you to do a tree. This quiz was originally 4 questions, but I wanted you to do a tree to help guide you. So I forgot to change that. So there's a couple approaches. One is just, I told students just think of it as 4. So that would be the probability that it's correct and correct and correct and wrong, or not correct. Okay, so that's the probability of correct times the probability of correct times the probability of correct times the probability of wrong. Okay, so that's going to be 0.25 times 0.25 times 0.25 times 0.75. And the reason we know this is because it's independent. They're independent events, so we can add another branch easily. So this would be 0.012. Now, if some people realized I made a mistake and said 3, then it would be the probability of correct and wrong. So that would just be probability of correct times the probability of correct times the probability of wrong. And I think we have one of those, don't we? Correct, not correct. So 0.047. Okay, and then some people said they called this 0. So there was a couple other interpretations. So okay, so that's part 1. That's page 1. I'm going to stop the video and then restart it back up.